Hello students, welcome to Saurabh Sir classes. Today we have started with metals and non-metals, and in our previous videos we have already discussed about the difference between metals and non-metals. That is from the perspective of physical properties as well as their chemical properties. What are the difference between metals and non-metals? Now we are coming to chemical reactions of metals. Now metals are, if we consider their chemical reactivity, their reactivity is not same for all metals, and you will find that there is a reactivity table, and accordingly we find that this reactivity table where the maximum reactive metals are taken at the top and minimum reactive metals are taken at the bottom. And we see that we have in this series potassium, calcium, magnesium, zinc, aluminium, iron, and next is our lead, copper, and AU, AG. These are the tables of metals we find, and these potassium is the maximum reactive metals, and copper, then this reactivity gradually decreases, and gold and silver, they are least reactive. Sometimes they are also called the inert metals. Now this how this reactivity is changing, what are the, if you want to give examples of this reactivity, we will see that in case of potassium or sodium, this reaction is, we are considering here, is reaction with, number one, reaction with water. Now if we react, if we add sodium or potassium in water, there is a vigorous reaction takes place, and sodium like water react to form sodium hydroxide plus hydrogen gas, and this hydrogen gas, what is formed here, which and this reaction is highly exothermic, and sometimes this gas burns, catch fire. In case of potassium also same reaction takes place, plus H2O, this gives KOH plus H2, and this hydrogen gas that gets catch fire when we are when this reaction takes place, because it is a highly exothermic reaction. But this reaction gradually decreases, or this vigorous reaction gradually this become less vigorous as we go down the group. In case of calcium, we required hot water. Hot water is required to make it calcium hydroxide plus water. So in this case we see that it is not working with the cold water, and its severity of the reaction is also decreased. And in case of zinc aluminum ion, in case of suppose iron, we need steam. Steam is required. In case of aluminum also, steam is required to react with them. Here, this may be aluminum or iron, where we are getting the corresponding uh, hydrogen gas and oxide of aluminum. Oh, sorry, this is, I am very sorry, this is sodium oxide, this is potassium oxide, not hydroxide. Oxide, this is also oxide. So oxides are formed along with hydrogen gas. Here also we get oxides of aluminum and oxides of iron and hydrogen gas. So, but in case of copper, copper does not react with water. No reaction. Even gold and Ag, they also have no reaction. Gold and silver also have no reaction. So this indicates that this reactivity of the metal decreases down the group. Since copper is non-reactive to water, we find that in some cases where we need to boil water, then this copper container is used. That is that so that this container is not get any type of corrosion. So, but in case of other metal, if you use suppose iron or lead or zinc, then in that case the water will react with these metals. So copper is safe for this type of reaction with water. So as it not react with water. Next we are coming to number 2. Number 2, is the reaction with acid. In general, we find that metal reacts with acid to form salt and hydrogen gas. Suppose if we have zinc plus H2SO4, this gives zinc sulfate plus hydrogen. So here we are getting the salt, zinc sulfate and hydrogen gas. But we see that as per the table, what we see that zinc is in the middle position of the table. Those elements above zinc, suppose we have calcium or magnesium, they react with sulfuric acid to produce hydrogen gas. But those below zinc, that is suppose copper, lead, they do not produce hydrogen gas when react with acid. They do not produce hydrogen gas when react with acid. So in that case, in their case, they copper, suppose in case of copper sulfate, in case of copper with sulfuric acid, we find instead of hydrogen, sulfur dioxide gas is produced. Similarly, zinc when react with nitric acid, reaction of nitric acid, HNO3 with metal, that gives corresponding salt plus water. Here hydrogen gas is not formed. Actually hydrogen gas is formed, but since nitric acid is an oxidizing agent and hydrogen is a reducing agent, they react in situ in the reaction mixture and forms water. So that's why we are not getting the hydrogen gas. Suppose if we have zinc plus HNO3, then this gives ZnNO3 whole 2 plus water. So here we are not getting hydrogen due to that reason, due to that oxygen is, the hydrogen is oxidized by the nitric acid present in the solution. And but sometimes we found that manganese and magnesium, they react with nitric acid to produce hydrogen gas. They are very slow reaction, and sometimes they produces hydrogen gas when react with nitric acid. Next is the number 3. This is displacement reaction. Displacement reaction. Displacement reaction. It is found that when a zinc rod is placed inside a copper sulfate solution, this gives us zinc sulfate plus copper. So this reaction, this zinc sulfate is produced along with copper. Here copper is replaced by zinc, but the reverse reaction is not occurring. If you take zinc sulfate solution and put a copper rod, then you will have no reaction. This is also due to this. This is also due to that reactivity series. That is, in the reactivity series, you will find that zinc is above the copper in the reactivity series. So those who are more reactive can replace the less reactive metal from its salt solution, but those who are less reactive, it cannot uh, replace the more reactive metal from its salt. So that reason, zinc cannot be replaced by copper. And this reactivity series, we see that zinc greater than iron greater than copper. So this react series, or as per this series, zinc can replace iron, zinc can replace copper, but iron can replace copper, but iron cannot replace zinc from its solution, from its salt. So this order is maintained. Those in the above in the series, they can replace those who below in the series. So this in this way, this reaction is not possible. Next, the reaction with oxygen. Next is reaction number 4. Reaction with number 4 or number 3? Number 4. Reaction with oxygen. You will find here that with oxygen, metal reacts with oxygen. Metal reacts with oxygen to produce metal oxide, which further react with water to produce metal hydroxide. So in this case, we find that metal reacts with oxygen to produce metal oxide, and which further react with water to produce metal hydroxide. Suppose sodium react with oxygen to produce Na2O, and this further react with water to produce NaOH. So sodium hydroxide is ultimately produced, and this is basic. So sodium oxide is called a basic oxide because it is producing base when react with water. But in case of Al2O3 or ZnO, zinc oxide, we find that these two oxides, they can both react with acid and base. That means Al2O3 and ZnO, these are called amphoteric oxide. That means they react with both acid and base. Okay. So these are the reactions of metal with oxygen. Now if we see this aluminum oxide, Al2O3, that react with HCl, this gives AlCl3 plus water. Similarly, Al2O3 react with NaOH to give NaAlO2 plus H2O. So we see that aluminum oxide reacts both with acid and base. So it is an amphoteric oxide. Finally, reaction with non-metal we see that metal reacts with non-metal that to produce a salt. Suppose sodium reacts with chlorine to gives NaCl. This will be 2 and this will be 2. NaCl. And this NaCl, it is mainly an ionic compound with high boiling and melting point and have a conductive property also. So this metal and non-metal always reacts to produce a salt, and which is a ionic compound. So that's all about the chemical reaction of metals. Hope you have have a clear idea about the properties of metals. Thank you very much for seeing this video.